Yes, it's time for a rare science video today because this topic is so important to your future chemistry in high school that I want to make sure that we get it. And also, half of what you're going to see today is not in the book, but it will be expected that you know it in chemistry in high school. All right? So make sure you take good notes. All right? You could even follow along. This is page 160, 161 in your science books. All right? We're going to be adding a bunch to it that is not found in your books. It's going to come in really handy though. And so you'll be on top of the game when they talk stoichiometry in chemistry in high school. All right? So our topic today is this idea of something called formula mass. All right? Formula mass. The whole chapter's been about formulas. Chemical formulas, right? Oxidation, reduction, how atoms come together to make a compound, all right? And how we name those compounds, with the element that gives up electrons comes first in the formula name, and the elements that receive the electrons come second in the formula name, all right? So the idea of formula mass is literally the idea of weighing molecules. How much do they weigh? What's their mass? All right. We've talked atomic mass as the sum of the neutrons and the protons. All right. The average of that. And we use that atomic mass, the mass number, rounded to the nearest whole number. All right. In this whole thing, we're not going to use decimals as far as atomic mass goes, all right? But formula mass is simply a matter of counting atoms and their mass. If we take something like H2O, water, all right? We realize that we have 2 hydrogens and 1 oxygen. If we look on the periodic table, all right, and we look at the mass of hydrogen, it'll tell you 1 point, blah, blah, but it's really just 1. So this hydrogen atom, the single hydrogen atom we say has a mass of 1. That one has a mass of 1. And if we look on the periodic table for the idea of oxygen, all right, we look up, there we go, on the periodic table, we see that it's got a mass of 16, all right? Now formula mass is no more difficult than adding these 3 numbers together to get a total mass number. 1 plus 1 plus 16. So we say that the formula mass of water is 18. And so you're thinking, well, yeah, okay, what does he need a video to tell us this about, right? Well, you know, like all things, it can get a little more intricate, all right? Let's look at some other examples here. All right. We talked about the, let's take table salt, all right. Sodium chloride, all right. And if we're asked to find the formula mass of table salt, first thing we do is break it into the elements involved. What are the elements? NaCl, well, that says we've got sodium and we've got chlorine. And then we look at the mass of these elements. Sodium has an atomic mass here of 22.99, so we're going to say 23. And chlorine has an atomic mass of 35.45, so we're just going to say 35. So we add them together. 1 sodium and 1 chlorine gives us a mass of 58 atomic mass units, AMU, all right? And in its simplest form, that's formula mass. We can look at more intricate compounds, all right? Something a little more interesting like sugar, C6H12O6, all right? Well, this says we've got 6 sugars, all right? Carbon, all right? Carbon has a mass of 12, right? Yep. Carbon has a mass of 12, but there's 6 of them, so I have to multiply that times 6. hydrogen has a mass of 1, but there's 12 of them, so I multiply by 12. And oxygen has a mass of, what do we say, 16. So I gotta multiply that times 6, all right? Because there are that number of atoms in one molecule of this type of sugar. So here we get 72, 12, and 96. We add it all up, 8, 9, 180 atomic mass units for one molecule of sugar, all right? And that's pretty much where your book stops, all right? It says, look at the formula, figure out what the elements are involved, look at the atomic mass of one of the elements, see how many of those elements are involved in the formula, multiply that to get the total number for each element, and find the sum of all the mass numbers, and you have the atomic mass of this, all right? But what good is this? The book doesn't tell you, all right? I've told you before that when we do chemistry, you can literally count atoms. So now is your chance to count atoms. That was one way of counting atoms. But in a lab situation, you need to understand that formulas are actually ratios. H2O means you've got twice as much hydrogen elements as there is in oxygen, and so forth. So it's a ratio, and I hope you're understanding how valence electrons determine what the ratios are, all right? You don't have H12O. That doesn't exist. That's too many electrons hanging around in not enough space. There are certain ways that things go together, and that's the way it works, all right? Now, we can take advantage of this if we understand something called a unit of mass that is key to chemistry. And this is the idea of what's called a mole. Now a mole is a unit, just like, think of a mole as a dozen, all right? Same type of thing. A dozen stands for 12 of something, all right? A mole stands for a mole of something, all right? Used in chemistry. Except the number we're talking about in a mole, all right, since we're talking about atoms, we have to talk about a lot of atoms before we can physically start working with them. And so a mole is a number. It represents an amount, all right? And that amount is 6.022 times 10 to the 23rd power. That's a 6.022 with 20 zeros after it. It's a big number. That number has a name. It's called Avogadro's number. Avogadro's number. Pretty famous number in chemistry, and your book doesn't even talk about it. All right? 6.022 times 10 to the 23rd, Avogadro's number, or the number of atoms in one mole of something. Now, where did this times 10 to the 23rd come from? What good is that? Well, here's the big connection, you see. All right? If I talk about oxygen, say, well, let's do a solid. Let's say sodium. All right? And sodium has an atomic mass of 23, right? And so we say, okay, that's nice, 23. But here's the deal. If I have 1 mole of sodium, in other words, if I have 1 mole Na sodium, that means that I have 6.022 times 10 to the 23 atoms of sodium. All right? And guess what? If I have 1 mole of sodium, that amount of atoms of sodium is going to weigh 23 grams. The atomic mass goes with the amount in grams of 1 mole of that element. If I have a mole of, chlorine, all right? Chlorine 35 is the atomic mass. But if I have a mole of it, I've got 35 grams of chlorine floating around in my tank. The idea being that if I'm putting chlorine at 35 grams, I need to make salt in the right ratio. That's what I'm going to put together. I'm going to get 23 grams of sodium, and I need 35 grams of chlorine to have a 1-to-1 matchup. And that's how I use formula mass in the lab, to actually weigh out things in grams that we can measure in these units called moles. Right? So with that, you can do all kinds of things. If we talk about C6H12O6, sugar, all right? We said the atomic mass of that was what, 180? Or what was that? The atomic mass of that sugar, yeah, 180, all right? So that says that in this, all right, if I have 1 mole of sugar, I want to have a mole of sugar, all I have to do is measure out 180 grams of this stuff, and that gives me 1 mole of that. It means I've got a mole, or a total amount here in these ratios that work to this, 180 grams. 1 mole of something, all right? And 1 mole, remember, is 1 mole is equal to the atomic mass in grams. So that you can literally say that if I've got 1 gram of this, then I know exactly how many atoms almost you've got. It's a pretty good concept to have, all right? So you'll see things like H2O2 and ask what's the formula mass of that, all right? Well, you got 2 H's, that's a mass of 2. You got 2 oxygens, which again is 16 plus 16, that's 32. So the formula mass here is 34. That says if you have 1 mole of hydrogen peroxide, you can pour out 34 milliliters of that substance. And now you have some way of doing the ratios here, all right? Yeah, which says that if you're going to create hydrogen peroxide, all right, you're going to use 2 moles of hydrogen, or you're going to use 2 grams of hydrogen, and 32 grams of oxygen. All right? Because now we've got some number that equalizes things, puts the ratios in the same thing. So 2 grams of hydrogen plus 32 grams of oxygen can be chemically combined to make the correct ratio. All right? Twice as much oxygen as there is hydrogen. All right? So that's formula mass connected with the idea of Avogadro's number and the idea of now using that formula you've been studying in this chapter to mix up chemicals in the right ratios, because now you've got some amounts that you can actually mix together correctly. All right? And that's the idea of formula mass. And that will bring us to the end of the chapter. And the next chapter then will happen when we start talking about taking different compounds and putting them together in chemical reactions. So I hope this helped. And yes, moles will be on the test, so make sure you understand that. You might want to go through this one more time, put it in your notes, and we'll see you later.